Hi, I'm Bob. We will continue solving the exercises for Chapter 14, Oligopoly and Monopolistic Competition. We are at the Cournot model section. Let's solve exercise 3.13. A duopoly faces an inverse market demand function of P equals 120 minus Q. Firm 1 has a constant marginal cost of 20. Firm 2's constant marginal cost is 40. Calculate the output of each firm, market output, and price in Part A, a collusive equilibrium, or Part 2, a Nash-Cournot equilibrium. We first consider the collusive case. The two firms form a cartel and operate like a monopoly with respect to the entire market demand. The cartel's marginal revenue function can be written directly from the linear inverse demand function. The cartel's marginal cost should be 20, the lower one between the two cartel members. In other words, the member firm with a lower marginal cost produces all market output. The first order condition for profit maximization is marginal revenue equals marginal cost. We obtain the market output 50. It is also Firm 1's output because it produces all market output. Substituting the market output into the market demand function gives the market price of 70. Next, we determine the Nash-Cournot equilibrium if the two firms do not collude and simultaneously choose how much they produce. The idea is to use the firm's best response function to find the Nash-Cournot equilibrium quantity and price. Firm 1 faces a residual demand, the entire market demand minus the output from Firm 2. It operates like a monopoly with respect to its residual demand. We can write its revenue and marginal revenue functions. The first order condition for profit maximization is marginal revenue equals marginal cost. It leads to Firm 1's best response function. It is a function that relates Q1 to Q2. Similarly, we can derive Firm 2's best response function. We can simplify the two best response functions and solve them simultaneously to find the Nash-Cournot equilibrium quantities for the two firms. The firm with lower marginal cost produces more output. The market output is the sum of them. Substituting the market output into the inverse market demand function gives the Nash-Cournot equilibrium price. We can draw a graph to show the firm's best response curves and the Nash-Cournot equilibrium quantities. It is a Nash-Cournot equilibrium with unequal costs. Notice that the market output is higher and the market price is lower than those in the collusive case. Let's tackle exercise 3.14. Graph the best response curve of the second firm in solved problem 14.1 if its marginal cost is M and if it is M plus X. Add the first firm's best response curve and show how the Nash-Cournot equilibrium changes as its marginal cost increases. We use the firm's best response function expression from the textbook to show the Nash-Cournot equilibrium. we first draw Firm 1's best response curve. Its slope is minus 1/2. Then we draw Firm 2's best response curve if its marginal cost is m. Its slope is minus 2 if Q1 is on the vertical axis and Q2 is on the horizontal axis. We may rearrange Firm 2's best response function to help us draw the curve. If Firm 2's marginal cost increases by x, its best response function looks like this. Firm 2's best response curve shifts to the left, as shown in the graph. The Nash-Cournot equilibrium changes from E1 to E2. It shows that if Firm 2's marginal cost increases, its equilibrium output decreases and Firm 1's equilibrium output increases. Let's solve exercise 3.15. In 2015, Spirit reported that its average cost per available seat mile, excluding special items and fuel, was 5.7 cents compared to 8.5 cents for Southwest. Assuming that Spirit and Southwest compete on a single route, using a graph to show that their equilibrium quantities differ. The last exercise shows that as the marginal cost increases, the firm's equilibrium output decreases in the Nash-Cournot model. Suppose the average cost data reflect that Spirit's marginal cost is lower than Southwest's. So Spirit should have a higher output than Southwest in the Nash-Cournot equilibrium. We use math and a graph to show the result. Suppose the inverse market demand is P equals A minus B times Q. In the Nash-Cournot model, Spirit's revenue function equals P times Q1, and its marginal revenue function is as follows. The oligopoly firm operates like a monopoly with respect to its residual demand. The first-order condition for profit maximization gives spirits best response function. We draw it in the graph. It is a curve with a minus 0.5 slope. Similarly, we derive Southwest's best response function and draw it in the graph. Because MC1 is smaller than MC2, the equilibrium output Q1 star is greater than Q2 star. Spirit has a lower cost, and therefore it provides a higher quantity than Southwest. Let's go to exercise 3.16. How would the Nash-Cournot equilibrium change in the airline example if United's marginal cost were $100 and Americans were $200? In the Nash-Cournot model, the firm with a lower marginal cost produces more output. We use the data in the textbook to solve for the equilibrium quantities. In the textbook's example, both firms have a marginal cost of $147, and both firms produce a quantity of 64. Here, the United's marginal cost is $100, and it produces 113. American's marginal cost is $200, and it produces 13. Thank you for watching this video and subscribing to my YouTube channel. See you next time.